All right, so today, before we took the quiz, depending on if it's Thursday or Friday for you, this is the graph we took a look at. I wanted to do one last little bit of review. This file is posted on Classroom, so check it. I shared it with, not as an assignment, but just as an announcement. The link should be on there for this PDF file. And there are some questions here that you were supposed to have done. So hopefully, like before you watch the rest of this video, you should go and try to answer these questions for this graph and then tune back in, and then you can see those things being worked out. So this says find the density of the metal shown in the graph and show all work. Now, if you're looking for density, what exactly does that mean? Like what do you have to find about this graph if I'm asking you to find the density? And again, this is part of what you need to know about what density is, that if I ask you for density and you're looking at a graph like this, you should know automatically already that you're looking for the slope. So you need to find the slope. Okay, well then I guess I'll do that. And so I'm seeing, oh, that looks like a good spot right there. That looks like a really good spot. Perfect grid intersection. And as I look down here, ooh, that's another one right there. That's perfect. Perfect. So I can bring that across. I can drop that down. And there we have it. Now, I need to know the rise. Hopefully, you've looked at the graph here and you've seen that this is an interval of tens. So I'm counting 10, 20, 30, 40, 50, 60, 70, 80. So I have 80 grams here. And then hopefully you'll notice that across the bottom here, this interval is ones. And so I can just 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 mLs here. So then I scroll on down here where it says to show my work. And I say, okay, I'm finding the density, which is the mass to volume ratio. And that is 80 grams up top and 9 mLs in the bottom. And that is 8.9-ish grams for every ml. So that's the kind of stuff you have to show. You have to show, first of all, on the graph that you found the rise and a run, which is what you need for the slope. Then you'll show that you put the rise over the run, which is actually a mass over a volume, which is the mass to volume ratio, which is what density is. Now, how much mass does 13 centimeters cubed of this metal have? Is 13 centimeters cubed anywhere on this graph? I don't see centimeters cubed anywhere, but that shouldn't be alarming because you're supposed to know that centimeters cubed is the same as milliliters. So remember, a milliliter and a centimeter cubed are identical. We did that volume lab. It proved that. We talked about that. That's why, or that's how the metric system is set up. So that is the same as mLs. Okay, so what am I doing? Well, I'm going to 13. That's what it said. So I'm going to go to 13. Right there, 13. Then what? Well, I'll take a dashed line on up like this right there, up to the best fit line. Then I go across like this. Oh boy, that's kind of a, oh no, seriously, what the heck? So it looks like I kind of went up at the end. So right about there. Now, if this is 100 and that's 110 and that's 120, so I'm a little bit above 115. So I might say 116, 117, somewhere in that range. And again, it is an estimate. Okay, it is an estimate, but it's got to be a good estimate. And so I'd say 116, 117 would be the best answers. If you said 118 or 119, I may not be as happy with that, but I would still accept it. If you said 115, that looks like it's over halfway up. I mean, it's over halfway up in that box. So I think 116, 117 would be the best answers there. Then, what is the size of a 170 gram piece of this metal? When they say size, what are they talking about? They're talking about volume. Volume is size. So what do I do here? Well, I go to 170 grams. Where's 170 grams? Well, that's 150. That's 160, 170. Okay, so I go 2 boxes above the 150, and I take this all the way over to the. Oh wait, that's one of the. Oh boy, that's one of the places I used for slope. Oh, look at that! It's in a perfect grid intersection. So that looks like what? 19 mLs or centimeters cubed. Now, there's not really much debate about that one. If you said it wasn't 19, I would wonder what's going on with you. So there's not much guess there. It's on the line. So 19 mLs. That's how big a 170 gram piece of this stuff is. So what would be the mass of a piece of this metal if it was 35 mLs in volume? What do you do with that? What would be the mass of a piece of this metal if it was 35 mLs in volume? Is 35 mLs on the graph? Can I go to 35 mLs and then find out like how massive that is? I hope you're seeing that doesn't work. You can't do that. So you can't see 35. I mean, that'd be, that's way off the screen here. So we can't read this off the graph. So how can we figure this out? Let's think about density. Let's think about this slope here. This is a mass to volume what? A mass to volume what? Ratio. Oh, so it's actually 8.9 grams for every 1 ml. It's an 8.9 to 1 ratio. An 8.9 to 1 ratio. 8.9 to 1. Oh, wait a minute. I'm trying to point. I can't do it. I'm trying to point where that thing is down in the corner. It's an 8.9 to 1. But we don't have just one. We don't have just 1 ml. We have 35 of them. So what do you do then? Well, you have 35 times that mass, right? If every one of them is 8.9 grams and you've got 35 of them, then you've got 35 times that much. So do you see this is kind of a ratio thing? So it still has to be an 8.9 to 1. So it's kind of like a cross multiply and divide thing, right? Cross multiply, divide. So the unknown mass with the known volume here. So you're kind of cross multiplying here, right? Cross multiply and divide. Oh no. I hope the App Store doesn't open. Gosh, it does all the time. So cross multiply and divide. So if you do that, then it's 35 mLs times 8.9 grams here. So, oh gosh, it went to the pointer. Oh no. Of course, this has to happen right in the middle of me doing this video. Okay, it's back. 35 mLs times that mass times 1 ml. So I've gotten rid of this then. So this goes away on this side. This goes away on this side. And so now I guess if I want to rewrite this whole thing, it would look, oh gosh, this is a mess. 35 mLs times 8.9 grams equals m times 1 ml. Then I would have to divide both sides by 1 ml. Divide both sides by 1 ml. That goes away. And then mLs goes away. And this whole thing is just over 1 anyway. And that just means that it's the same of whatever 8.9 times 35 is, which is, oh gosh, like 311.5 maybe. grams. I didn't even check. I don't even know. Oh gosh, now I got to look at what is it? 8.9 times 35. 311.5. Yeah. Now, that's one way to think of it. Okay? That's one way to think of it. Which seems kind of complicated. I mean, maybe it isn't. Maybe it is. Maybe in your brain, that's complicated. Here's another way to think of it. All right? Here's another way to think of it. Let me get this stuff out of the way. How about we think of it like this? Didn't we say that density is the mass to volume ratio? And do we know what the density is of this stuff? Yeah, it's 8.9 grams for every ml. That's the density. What's the mass? Well, we don't know. We don't know how massive this piece is. How much volume does it have? 35 mLs. So what do we need? We need to isolate the m. We got to get the m by itself. Now, I know in math class they call that isolating the variable, and I know you've been doing this in math for like 3 or 4 years. So this is not the first time you've seen or heard the expression isolate the variable. We got to get the m by itself, and that's our answer. So how do you get the m by itself? Because right now it's being divided by 35 mLs. So now you have to multiply by 35 mLs, the opposite operation, which then puts the 35 on the other side, because you got to do that to both sides. So times 35 mLs times 35 mLs. I guess I can get rid of the dot if I put parentheses. Times 35 mLs. And so that cancels that one. And my m, that ml cancels the bottom ml, and I just get 311.5 grams as my answer. I like this way. I like this way because the whole cross multiply and divide, it kind of adds another step that you don't really need. But if it helps you to think in terms of ratios of an 8.9 to 1 and then a 311.5 to 35, if that helps to view it and think about it that way, then do it that way. That's fine. So that's what we had talked about. And then I asked a few questions like in the mass and change lab, if the mass of the steel wool went up, what does that mean? And you all said, well, it picked up particles from somewhere. I said, yeah. And so then what if in the sugar part, the sugar in the water, what if your mass went down? And you would say, well, that means we lost some particles somehow. Did we spill the sugar, or we shook it and water came out? So you have to have some way to explain why your mass went down. So hopefully you remember the law of conservation of mass, that your mass can't change in a system that's closed. And then if it does change, that means your system is open and that particles got in or out. And then hopefully you know that mLs and cm cubes are the same, and that both of those are units of measure for volume, and that grams is a unit of measure for mass. And hopefully you understand that the mass to volume ratio is what we call density. So all of those things is what you need to know for quiz or test, whatever you want to call it. So I hope that this little last little bit of review helped. And if you're not here and you have to take the quiz later, good luck, and hopefully you do well. Take care. Bye.